preparing the live stream. In 3, 2, 1. Everybody cross your fingers. We've never done this before. And we are live. Welcome, everybody. This is the July 1st, 2020 episode of the Baseline Show. And this is our this is not our first rodeo with the show, but it is the first time that we've had we've had it under the name The Baseline. So welcome everybody, Boris, Kyle, Daniel, Juan Blanco, Luis, Sam Stokes, Stephen Smith, Stefan Schmidt, Daniel and Boris. As I'm speaking, if you see any new participants coming in, we're using the upgraded security with Zoom. So we can just admit participants, and it's a lot easier than it used to be. And we are live streaming on YouTube right now. So it's great to have everybody here. We're gonna the format for the Baseline Show is really simple. We're here to answer questions from our community or people that want to join the community that need to know various things. You know, how to get involved, what's going on with code thing X, how are we organized, confusion about the documentation or the way things work in the community. Those are all great reasons to get on the show and ask some questions. So we're going to have some questions from people, and then we also are going to start having celebrity guests that we'll do some interviews with in the community around blockchain generally, and specifically around the use of public mainnet in business. So, and today we've got Kyle Thomas and Boris Rislov, who are both going to tell us about some of the work they're doing. Kyle, in particular, is going to talk about the upcoming. Kyle's a maintainer of one of the maintainers on the development team for baselining and in the standards group. And Kyle has been a really great team player for many different projects that were already coming out. And now he's helping spearhead the next big update to the way baselining works. And it's a big update, and it's going to require some explanation. So he's going to come and do that. So without further ado, let's get into some questions. A lot of people on the call today. And I know that there were in the community chat, I don't think this person has shown up yet, but there's some interesting questions about how does this actually work? Why is baselining important for keeping systems in a state of consistency, and some other interesting questions. So what questions have you got? If you've been on the show before, I'm going to pause for an uncomfortable 7 seconds while people screw up the courage to ask a question. So please go ahead. All right, somebody's got to step up. Nobody ever wants to ask the first question.
We can go with our interview, and we'll have a lot of questions as we go through.
Well, there's that.
Step up. We can do that.
All right. Yep. No worries. Although I will say that we'd like to start with the question.
That's fine. I mean,
but if there are no questions yet, sometimes the interviews will prompt them. So feel free to get those questions in, and please use the chat if you'd like. We'll be watching both the YouTube and the Zoom chats. All right, so Boris, why don't you go first and tell us what you're doing, who you are, and what's going on?
Sure. I'm Boris Rislov, and I'm collaborating with Luis Suarez, who is also available here. So, and basically, we did get interested in Baseline recently, and I've done quite a bit of work in the financial industry, specifically, mostly in banks in New York, and so that like if the mainnet can become like a reality for the banks, that could be a huge benefit. but probably not for every product, but probably for quite a few products that banks trade or process between each other that could be like a great benefit. And so what we basically did, we were considering a project. Let me share it and I'll kind of go through a specific use case that we were thinking of. And I'll share, please tell me if you can see my screen. Okay, do you see it?
Yeah, that works.
Okay, so
Pictures, nice.
Yeah. So basically, what we did, what I was thinking of, there are scenarios where banks, obviously, I mean, they trade products, and they want this to be as secure and basically very private between the banks. And in the liquidity, potentially, the government wants to actually see what the liquidity is and actually what's being traded. But again, it has to be very private. Between the banks and the government. The government can obviously see every trade and everything that's there. So we picked, as an example, we picked a repo, which is basically a repurchase. It's an agreement of a repurchase where basically one entity is looking for cash. They sell a product. An instrument, in this case, it's a treasury, and what they do, they get back cash. The agreement is that they will hold the cash, they'll sell the product and hold the cash for a short period of time, usually. It could be overnight, it could be for a couple of days. I mean, months, it could be months also. But in this case, basically, they sell a product on September 16th, and they get back, they sell something that's worth $10 million, they get $10.2 million in cash. On the 23rd, basically the agreement terminates, so they return the product back. They get the product back, and they return the cash with interest. And at the same time, we have the government here looking at potentially what's the liquidity, because a lot of these transactions are I mean, they happen on a daily basis, and they would like to see often. I mean, some of these are like in thousands, some of them are in millions, which is probably not a very good use case for us to look at. But when it's in thousands, they would actually like to see what has been exchanged and what is the dollar flow and so on. So
this definitely looks like a baseline pattern. And
yeah,
you seem to know what you're doing. Some of the maintainers of Baseline are on the call today, so you know, they might want to have a conversation with you and Luis later on about
sure. Yeah.
more.
Yeah.
Do you, one question I have for you is this on the Baseline roadmap? Have you put this into an Epic yet?
No, we did not. No, we did not.
That would be awesome for you to do, and if you need help.
Sure.
I can tell you that. So let me help others by helping you on this.
Sure.
You know, to become we have two bodies in the Baseline protocol. We have the technical steering committee, which effectively manages any kind of disputes that might come up with the maintainers, which actually has been a pretty boring job so far because have been no disputes among the maintainers. And then we have the SSC, which is the steering committee. Think of it as like the front of a sprint. So this is and anybody can be on the SSC so long as they are named in an Epic on the roadmap. If you're accountable for something, you're on the SSC. If you're not accountable for something, you're not on the SSC. You can still join the meetings, but you're not on the SSC. So that's a really simple kind of binary thing. So if you want to be on the SSC on a regular basis and provide accountability for a project like this and keep it in front of people, get more support for it, get people helping, then you want to be on the SSC. And all you have to do is give me your GitHub ID and your email address. I'll invite you in. And as the pro tem chair, I can do that. And then we will, then you can put an Epic, flesh it out, and then generate issues and, you know, tasks and all that stuff underneath that Epic.
Okay.
And we keep track of it every week or every 2 weeks.
Okay, sure. Yeah, we'll definitely consider that. So I guess the question is, and Louis, actually, maybe you want to introduce yourself? I kind of like skipped over it. Maybe it's a good time now.
Yes, sure. So my name is Luis, and I used to work for Consensus in 2018. I was a Solid developer at Token Foundry, and I had the opportunity to work with some token sales. And so I've been working and helping Boris regarding baseline for the last month. And so that's it.
Okay. So a few questions we have, and I'm sure Luis will probably get into a little more detail. So we're trying to better understand when basically like, I mean, we understand the data resides actually in the database. So none of the data actually leaves bank A or bank B. It's all kind of physically is in, only the signature is being provided to the baseline. How does the signature actually, or I mean, the other side, like in this case, bank B, I mean, they need to know in great detail actually what the transaction was, the maturity, the amount, the dates. I mean, there are quite a few details they need to. Is that that's all being handled by the zero proof knowledge or like by the algorithm? What needs to be done for that? I mean, that's kind of where we have a question.
Yeah, so there's a lot of folks on the call who can also answer this question. I'll start off, but I'm going to invite any, there's Brian on the call. I think I saw Kartik and Kyle is here, Stefan is here. But I'll just start the bidding by saying that, one of the basic things here is that, yes, of course, the only thing that's going on the mainnet is the proof. And it's being put there, the zero knowledge component, friends keep me honest, is there to help with what we're putting on the mainnet, even though it's not the actual data. You want to make sure that there's still a lot of noise, as randomness is effectively that what those people could not get information about, even the meta information or the trace data of, well, let's look at the volume of activity. Oh, I can clearly figure out that there's a pattern of behavior between these accounts or these parties. So by putting these into a shield contract and using some zero knowledge, we obfuscate even that so that the mainnet is effectively, looks like noise and sounds like a metronome. There's no information coming off of it unless you're in on the secret of a particular record between two baselining parties like bank A and bank B. So think of it this way. If zero knowledge is succinctly said, I have a secret, I'm going to prove to you what the secret is without telling you what the secret is, right? I'm going to prove to you I have the right secret. Baselining uses a little bit of zero knowledge to say, we have a secret and we are going to use this other machine, the mainnet, to make sure to confirm that we have the same secret without telling that machine anything about our secret.
Okay.
And anybody observing that machine would not even know that we had a secret to share.
Okay. So in this case, the regulator of the government, they would be observing multiple banks. I mean, they'll be observing.
In this case, the government would have its own, as you say, Oracle. They would have their Oracle database. They would be getting the serialized message from the initiator. And so they have the data and what the mainnet is doing. It's a very constrained thing it's doing, which is good, right? TCP/IP does a very small number of things, but it does it for everybody. Here, it's, the mainnet is just doing ordering and hash management effectively, right? In a clever way. And by doing that, the government can say, this record we've got is verifiably the same one as these other parties. And that's it. That's what that so it's not, so the hash it's a hash, but instead of being a proof of existence hash, it's a proof of consistency because of the way we laid that hash down, right? The hash is saying it's not just a hash saying, here is a record, and if you produce the record and it's the genuine article, it will pass the hash. In this case, it's saying we can prove that everybody got the data, deposited it correctly, ran code if there was code involved, got deterministically the same answer, and none of us can say we didn't get the memo. So we eliminate non-repudiation.
Maybe we get a bit more in detail, but I'll ask the question anyway. Will they know that it's actually that action happened between bank A and B? Because bank A will be, let's say, an entity, and bank B will be another entity or counterparty. So because from the regulator perspective, will they know that actually that transaction has been completed between those two counterparties?
They may know in two ways. One is if the data itself contains that information, right? Data is not going on the blockchain. It's going by a private peer-to-peer messenger between the counterparties, including the government in this case. And so if there are, if there's data for that in the record that's been serialized and sent, then that's one way, right? That's pretty obvious. And then they can look at their record and go, yeah, it's a baseline record. I know it's verified. I know that that nobody's been tampering with it. I know that everybody else has the same information. And here it says bank A and bank B. The other way is, and if Karthik's on the line, or maybe Kyle can also answer this, and we can pivot that into Kyle's work. Because you're all in a work group with a Rolodex effectively that connects you, there may be a way to at least verify that off the mainnet how the counterparties for that transaction. But as I say that, I'm thinking maybe not, because one of the things we're doing here is obfuscating that. Kyle or Karthik?
Hey.
I was going to add something just real quick about the diagram. Maybe it'll help, but this is Brian here.
Hey, Brian.
For this diagram you have here, Boris, I think there needs to just be an additional line. Maybe it's obvious, but the regulator would have to go to Bank A and retrieve the signatures and messages that were sent. And then they could independently go and verify that with what was put on chain.
Okay, that makes sense. Yeah.
So that, I guess,
or they could get it right, Brian. They could be a counterparty in the event itself, and then they would get it at that time.
That's what I was going to tack on.
The work group, but if after the fact, the regulator comes in and says, "Okay, I want to see all the business between the two banks." The regulator can't go to main chain and pull in that information off, because you can't make sense of it. You have to go to the source, the bank, and say, "Okay, give me all your records." And then they can verify those records and those transactions with what's on the chain. So the regulator has to have access to the private information to then generate the public information that then you can verify with the ZKP service of the artifacts that are put on chain. Does that make sense, or does that help?
They would need to get it from both counterparties, or just one would be enough?
Just
it depends on what they want to look into. And it depends on the nature of what the messages contain and what's being sent back and forth.
Okay.
So,
I think the short answer there is, if it's baselined, then they only need one, because then they can prove that it was correct. And then you're just, you're into standard hashing technique, right?
Okay.
So again, what's great about baselining is how boring it is. This is not like magic pixie dust science, right? This is fairly straight up stuff. Related to that is what the subject of rebasing and debasing a record. So, one of the benefits of baselining is that you're running your own database and you have control over that database. You could change the record. If you do, you've debased the record. If you've done that out of sequence, or if you've done that without, again, reasserting the consistency check. So in that case, you've debased the record, and you'd need to rebase it. Brian's point about the government needing to querying the after the fact would be similar to that rebasing activity. They would need to get the data from some set of counterparties, and I think there's a whole set of services around rebasing records that have been baselined that can come up in the future. It might be a pretty good business to be in fact. Okay. And I think that with that, we answered a question that M. Yule in the on YouTube was asking about what happens regarding why are we storing this proof on the mainnet? How does that help in having the data be private and synchronizing it between parties? And I hope that begins to answer it. There's also information about that in the docs, docs.baseline-protocol.org. And in there you can, what you'll realize is that the proof itself is not all that important. The proof itself of a single workflow step is, will give you the consistency check. But what's really interesting is that you can also use that as a state marker. You can say, well, our current state in this particular agreement is this figure, and that hash will represent that, and then you can nullify it later if you update it. And in doing that, you are able to use that proof in subsequent workflow steps for flow control, for ensuring that there's continuity from workflow step to workflow step, that's workflow step B followed the rules inside some kind of business logic inside workflow step A. So a purchase order has to follow the rules of the master service agreement. The master service agreement has been baselined. Its code, it is embodied in either as a zero knowledge circuit or in a code packet, and then can be, or a container, and then can, you're maintaining consistencies there so that subsequent workflow step, the PO, can't get its proof on the blockchain without following the rules of the master service agreement. Fun with hashes, we'll call it. Boris, is that good? Are we?
Yes. I mean, I do have more questions, but we took 20 minutes, so.
Well, this is wonderful. We'd love to see this on the roadmap.
Sure. Yeah.
Okay. So if you stop sharing your screen, then we can move on to Kyle, and I'll keep an eye out for questions, and we'll.
Thank you. Yeah.
Go to the end, and yeah.
Alrighty. It says I can't share yet, but I will. Good stuff, Boris.
Thank you.
Oh, you can't share yet?
No.
Oh,
I
I'll
will.
fix that. Hold on, I got that.
It's all good.
I got you.
No worries.
And you can now. We're getting used to these new tools. We've switched from webinars to this. Okay.
All right. So I guess a good segue there is the concept here of an atomic workflow step. So what we've been so I want to talk about init core today and where that stands. We've made pretty significant progress towards generalized and abstracted protocol packaging from the learnings from Radish 34 and various demos and POCs, for example, the SAP and Microsoft Dynamics POC. We can sort of, there's a couple of things I want to do today. I want to sort of walk through this diagram and sort of talk through some of the decisions, or some of what's here today and what's sort of part of the design that we see for for the near term. And then I want to talk about what the anatomy of one package in the protocol looks like. And then I want to look at a very simplified sort of reference implementation and what that looks like. So the first part here is, sort of the architecture for, hold on, this list is, there we go. Zoom is in my way there. So the first part of this is what we'll call like an atomic workflow step. And there's a few assumptions, that you need to have when you're looking at this diagram. One is that there's an established work group already, and you'll see some of this a little bit later when we talk about the reference implementation, or the interface, if you will, for the work groups. But assuming you have a work group, assuming you deployed a circuit, the baseline circuit, if you will, which meaning like just we've created a very generic document like circuit that you can use just to prove consistency and sort of lineage between workflow steps and documents. So to get into it here, assuming like user input, right, from like an ERP system, you know, you go into this upsert mode for a record, and what I mean by a record is whatever that record is, you know, in the system of record. And so there's some workflow, there's some logic around like what business process that record may or may not be tied to. And so if the answer to this question is yes, baseline the record, that sort of means that the record is part of a process, and that there is a circuit in the work group for handling the baseline protocol. Like there's a baseline, the baseline protocol applies to the record. So I think this is this entry point here was sort of the majority of the confusion around this diagram I got was around how this, you know, what this actually means. And so it means that like the record applies, it should be baseline. If the answer is yes, here's where what we're going to see today in the core packaging, like this finalized flag, there's not a finalized flag yet in the agreement or in the circuit. Or you know, on the baseline side of things, but I think we're imagining this to be this finalized flag is to be like a 1-bit flag that's like, you know, it basically could be the indicator whether or not a workflow step has completed to the point of termination in the sense that maybe we could actually tokenize the underlying documents or series of documents in the case of you know, a workflow that's been going on for some time. So we'll skip over tokenization for now. You know, this is a init core, not init tokens, but that'll be a fun one too. So essentially, if the record is not finalized, it means that we're still in the middle of the baseline protocol for the record. So basically, we need to figure out how to apply another commitment. Like how do we push the process forward and apply our changes to the record, which, you know, essentially could have happened from some unsuspecting user that's just using their existing ERP in a very boring way that they do today. So there's basically like we're recommending like a mutex, an off-chain mutex should actually be shared among the work group. There's a couple of different open source, like Redlock comes to mind as one that works pretty well. It works with Redis. It's like a distributed lock that's off chain, and that's just basically to protect against a lot of most race conditions. You know, in these early POCs or integrations, when you just have users updating an ERP system, we're going to be able to, you know, really knock off a lot of potential race conditions and the need to like automatically rebase commits and essentially like punt some of that complexity to a later time. But it'll knock out probably 99% of any weird things that could happen around races if two parties are trying to basically push a commitment onto the process or into the protocol at the same time that's based on this, like the same head commitment. So once you resolve, so what resolving the context means is going to the blockchain and getting the latest root out of the latest calculated Merkle root out of the Shield contract for that workflow, for that context. And then you're basically, you think about, I like to use GitHub as an example, and maybe it's like a loose example at least, when you begin a commit, like you're basing it on some base commit. When you do that, you're essentially you're going to push you're going to push another, you're going to push a set of commits on top of that, and it's sort of similar in that sense, like that we're going to, you know, use this resolved context and this resolved root. We're going to apply our mutations to the record locally and in like an atomic way, and then we're going to recalculate the baseline proof. And so, Karthik, would you like to talk a little bit at this time about proof generation or anything around this this part of the diagram? I know you had quite a bit of valuable input around here.
Definitely. Thanks, Kyle. So here, as Kyle was covering, on one side, on one part, as we're leveraging the secure messaging services to communicate messages, and also we are leveraging the blockchain to be able to make specific RPC connections, to be able to interact with the blockchain, to essentially either deposit proofs in the deposit proofs or commitments into the Shield contract, or to verify that contract as well. So this particular flow here is particularly referring to what happens between post secret message communication or secure message communication. What would be the order of interactions or the sequence of interactions that, or what could be the sequence of interactions from a proof generation point of view, both from off-chain using ZKP type services and verifying that proof on-chain using the mainnet. So we try to capture this as part of a general proof generation workflow or a subflow, where we're saying is that every update to a document, or essentially what we are postulating is that at the basic minimum, for every interaction that needs to be hidden, or essentially be in the language of baseline protocol, to be compliant with the baseline protocol, or to be compliant with the specification, we are trying to postulate a basic circuit which essentially captures all the essential information that is necessary to, say, start a business process. So, for example, in the previous implementations or POCs, one might have seen how we are using a generalized document circuit, which essentially, or as a proof, which essentially proves the fact that two parties are privy to the information that the document contains, and the truths about that document, such as the document has been signed by two different parties or n different parties, depending on the number of parties involved in the interaction. But we're starting with the most basic case of two parties. And also the other essential thing that we saw as a pattern in Radish 34 was that how every business process can be linked to a prior business process. So to ensure that not only are we staying consistent in terms of the representation of the data and the proofs on the chain, we also need to make sure that every time a new proof is created, or every time a new process needs to be say proofed or made baseline compliant, it would need to have an association or a linkage to the prior process or the prior proof. So in a way, we are trying to achieve linkability of the different proofs or of the different business logic executions on the mainnet by virtue of using something called Merkle trees. So we start with calculating the root of the full Merkle tree off-chain. And the idea is that we maintain the state or synchronized state of this Merkle tree both on and off-chain. When we talk about off-chain, we talk about how it is being dealt with from a NATS perspective, i.e. using the Nethermind provisions over there, how we are able to create new, insert new leaves, or insert a leaf, or insert a set of leaves, and so on. Then this is the off-chain side of the Merkle tree. The main idea is that the state of the different leaves or different units or storage units in the off-chain must tie out with what is correspondingly represented on-chain in the Shield contract. And that's where to have the tie out is where we essentially compute that proof. So the proof essentially involves the calculation of the baseline proofs now involves proving that the fact that the two parties have agreed upon the terms of the document, i.e. the standard things that we've been doing with baseline. But the essential thing we are adding is that the proof must also prove the fact that it is linked, or sorry, the process must also include the proof that it is linked to a prior process. And that's where we calculate the root and make sure that the root of the Merkle tree as is calculated on and off chain are consistent. So all in all, what we are essentially trying to do is that every time we are talking about baselining a document, particularly in the context of zero knowledge proofs and Merkle trees and blockchain, is that the every document can be seen as, at the basic instant itself, as an updatable context. So every update to the document or a set of every update to a document in that manner can be seen as a set of proofs with some base circuit for consistency and state change validation checks. So this is like the last few minutes I've been speaking specifically around how how we are postulating on how we can have a generalized circuit to start with, so that every subsequent custom circuit also, or a custom business logic, can be linked to say a standard business logic, something like what we are proposing here in the baseline document circuit.
So Karthik, you're pushing basically a code package or a container to the counterparties. They're executing that. You could have written that in Python, say, right? And then as long as everybody's running it the same, and you're careful not to introduce non-determinism like time lookups or something, or using oracles for that. You could just write this entirely off chain, and then the ZK circuit is effectively checking that something was run the same, and that's all it really knows. Is that a fair way of summarizing?
I mean, I think it is. Yeah, what we've built here is, sort of laying the foundation for composable circuits. There's still, a good number.
So that's the even more interesting and important thing is that. So you're saying the basic circuit could be used every time, but you're only getting you're just basically getting a consistent or not consistent result, as opposed to a check on correctness. So in the existing previous code base, the MSA circuit was custom built by EY, very nicely, I should say, to check the correctness. So it was doing a lot more than just consistency. It was saying this master service agreement doesn't have any gaps between rate A and rate B, for example. Right?
Yeah, the idea is to allow. Thanks, Karthik, for that. That was excellent. The idea is to create this generic circuit that can then be extended based on the business process. For example, I mean, every use case is going to require a circuit that represents that use case. And so
or it could just be code off chain.
But still that would be but still you would need probably maybe we will have a generic like off chain execution sort of circuit that would extend this, right? Like I still think there would be, to the point, not to go down that rabbit hole. There's still some good research to be done there. So sort of to wrap this up so we can move on. Once a transaction like is actually signed at the end of the process that started up here from the ERP system. Essentially, like that, you can release the lock that was acquired if that's in play, and we're going to present sort of the best way to do that, and like we'll show how to acquire a lock.
It sounds like this is a real opportunity to make money for some folks who are skilled at developing circuits, because like a regulator might want to develop a library of specialized circuits that enforce some correctness on a set of counterparties. Maybe your auditor will give you an easier time with your gap audit if you've run everything through a set of libraries. So it sounds like that's an opportunity for some business. Is that right?
Well, that's the hope. Like that's sort of the way we're positioning our business model at Provide. Certainly, we think that's a problem. The zero knowledge is a 6 to 12 month problem that's still going to have a lot of outstanding issues. And so, right. I think so.
Karthik, sorry, I'm just gonna. There's a bunch of stuff I think need to be public service announcements here. Karthik, are you? Is EY in the business of selling the development of circuits? Is that something you guys provide? So if somebody wanted custom circuits, do you guys provide that?
Yeah, I mean, we can definitely say that we have been dealing with zero knowledge proofs for some time, so we are fairly comfortable in writing up those circuits. But to clarify, these circuits are analogs, or if you will, of what we have been dealing with as smart contracts. So it's not like a complete replacement; it's like a sidestep to make sure that proofs submissions can be done off chain. To your question, yes, in short, we have had some experience, but like all other new languages and all other new programming constructs, these circuits also are relatively new. So it takes little time to get used to the parlance, but they're not that different from other programming constructs or in
Right,
procedure.
but a circuit is effectively, if you don't mind me interrupting, you're turning some logic into math, right? Addition, subtraction, and multiplication specifically, right? And so there's some expertise involved in doing that. Once you've done it, you have that library, you can just reuse it over and over again. So there's extra work, it's cost, it's effort, and they're going to be more expensive transaction wise. But they may be worth that especially if you have to assert correctness on a set of counterparties, right?
Yeah, I didn't quite follow the transaction expense part of it, but yeah, I mean, I think there's some work, sort of front-loaded work to model a business process into a circuit, and certainly the amount of times that you're updating the Shield contract to that extent, you'll be paying for that.
Okay.
Maybe I misunderstood exactly.
No,
what
I think that's. Yeah, no, the cost of developing them is. If baselining,
I thought you meant transactionally.
If baselining required somebody to write a specialized, complicated circuit for every business logic component in a workflow, that would not be a very repeatable thing. But because you have this base contract that you've just been describing, the base circuit, then you can use that for most things. And then you can, as regulation or auditability requires, you can maybe develop libraries of more specialized circuits coming forward. And I think that might be a
great opportunity for the community. Yeah. So to sort of land this plane, so part of this effort has been to really simplify the architecture. Radish 34 provided a good sort of working real world use case for people to see. It was very difficult to understand just from a developer development and a protocol perspective, in part because it took a lot of resources to run it. And so part of that was sort of looking at part of this process over these past few months has been to look, sort of looking at that architecture and understanding how to design something that the community can really understand. And so as a result of that, we created and designed like sort of the first iteration of a baseline JSON RPC module, which does, like, its initial responsibility is off-chain Merkle tree persistence. And Thomas, would you like to hop in? And Thomas has been very instrumental in helping fast track that effort. And so like while Nethermind is represented here in our diagram, just to be clear, it's easily like other Ethereum clients could implement the JSON RPC spec that Thomas and I have designed over the. So Thomas, do you want to say a few words about any of that, or is it pretty straightforward?
So to be clear, Thomas, and by the way, great to see you. Nethermind isn't. This graphic shouldn't be interpreted to mean you have to use Nethermind, but out of respect for the fact that you put it in the work, it's in here as the example for this particular.
Well, as of right now, you do need to use it, right? Because no one else has implemented it. But we do have a plugin.
But anybody could implement that, right?
Right. And a similar thing goes for Nats, right? So like there's a few opinions here, but you'll see momentarily, and we can move on because we're this discussion it's good, but it's probably a little over schedule. So like Nats is like sort of a prescribed thing in the protocol currently, but it's modular. In the sense that you could use your own. I mean, like I would recommend that you hear our argument for why to use these specific tooling, tooling first. But it's certainly modular.
So in the previous work, we used Whisper, and now we're using Nats in this update, correct?
Yeah, and Whisper, and you'll see that Whisper is still supported as a module as well. So you'll actually be able to see how to add modules in just a moment. So the last point to make here is as records are updated, your counterparties receive inbound messages on the point-to-point NATS channel subscription, essentially, and those messages flow into the same process, right? That's how you receive your updates. So each organization in the work group would be running this infrastructure, and that's it's sort of the first part of what I want to talk about. Let's move, I guess, forward quickly. The other two pieces I wanted to share was one sort of the anatomy of a protocol package, like a core package, and then an example app. So basically in the init core branch, which is now like 800 files big and 138 commits ahead and growing. It's essentially, we have a baseline in the core repo. We have a baseline package or directory, and then we have a lib directory, and then we have a core directory. If you follow the path into core, you'll find a set of npm packages that represent just sort of the core way to interact with the protocol. And so over the coming few weeks, we're going to be sort of finalizing this and adding like really rich documentation. So like if we look at like one of the API, like the API for example, package, there's an npm package at baseline protocol/API. You could npm install it, and essentially we have sort of a common interface, and so you can and you see here like there's.
Yeah, let me stop you there. I know you were going to hand it over to Thomas, and then you got into this. So
sorry.
I want to make sure that we flow it. I know you're so excited about this stuff.
No, I'm just trying to get it all in for you.
Yeah. Thomas, did you have something to say there?
Yeah, sure. Obviously, I can add a bit about this RPC interface. So we were thinking about bringing the similar feel to working with baseline as you would feel with working any module that belongs to Ethereum ecosystem when working with clients. So JSON RPC is obviously the main way of interacting with the nodes for all the developers, at least the main way for this lowest level as you operate with Node directly without any third-party providers. And we just added a module named Baseline here with ability to do the most basic set of operations that you would expect from a node to help you with, and that are related all to the actual storage of the data with the Merkle trees that you have in Baseline. So it's all about adding data and verifying. So even the verification methods here are just there to simplify the process for the new joiners to the baseline ecosystem to be able to verify quickly that they understand the flow. And so later they can use it as tools for any integrations of the Shield contracts with their systems. And this is already available and deployed in the latest Nethermind releases. It can be replicated and used in baseline in the future. And I think that maybe there will be some changes, but so far, based on what we've seen with Kyle, this is this simple set of methods that we needed.
Well, kudos to you. Let the history be shown that the first RPC for baselining to a node was done by Nethermind, and you showed the way. So, and it's a great example of what we need to see in across all sorts of things like SAP and Oracle and Sybase. I saw Sybase in Boris's slide. I was at Cal but way back when Sybase was starting, and I remember Sybase well. These systems are going to have are going to want to incorporate the elements required for baselining, and you've done that. So good on you. So moving forward from that, we are running out of time. So I'd like to ask you guys, both Karthik and Kyle, Tomasz, and others that have been working on this, one real simple question. Because in this format, we can't go through everything, and there will be lots of documentation. So let's ask, here's my questions. 1, when do we expect to see it come out? 2, what help do you need from the community, if any? And 3, this is the most important one, how will somebody who is already working on baselining stuff with the existing code base, what is the first step that will cascade into all of their steps for them to know, to make sure that they know how we've moved the cheese, right? How they're going to have to do things differently in this update.
Yeah, I mean, I think that the next thing I was going to share is probably going to like drive some questions and be sort of illustrative.
So first question, how soon? Are we talking July, August, September next year? we're not going to lock you down to a date.
Yeah, I mean, I think we're good to sort of stay on our path of documenting and getting this getting this thing shipped. I mean, there's an example application right now that in here that's coming together quite nicely that shows what a baseline app looks like and how to import, like for example, how to import the API messaging and privacy packages.
Right. So I'm just sorry. I'll stop you there. I feel like a journalist here. I'm just. Are you running at a July kind of time frame or an August kind of time?
Yeah, definitely July to be able to.
July it is. Okay. And the community will forgive you if it changes, because that's the way development works. But you're saying that you're running at getting all this stuff out in July with good documentation.
Mm-hmm.
Sweet. Okay. So
the focus is that it's going to be incremental. That is the key point.
Incremental. That's right. So something's going to be released in July.
It's not going to be one big code drop and you have to rebase all your masters. It's not going to be that. It's going to be incremental.
Well, and so that's the third question. Let's go to that one right now, which is, what in that next increment do you guys think people are going to want to be mindful of if they're working on stuff right now? What are they going to be what should they be thinking about in terms of likely changes that they will have to encounter when in July and August and certainly let's talk about July. That they're going to encounter when this comes out.
Yeah, they'll have to import, and rely on these new packages, which will be helpful because it'll probably remove they'll be able to remove a lot of code potentially that they're having to deal with right now themselves. That's sort of done off, in a one-off way everywhere, and this will start to standardize on a common set of a common set of packages and the protocol.
And where will they find, like if they were just stumbling into the repo, where are they going to find, where's the first place they're going to want to go to, as the update comes out? Is there going to be a new folder that's going to be seminal for that?
Yeah, I mean, it's probably going to be under, I think we may want to rename baseline to core. But it'll be like under the main repo right now.
So there will be a new. So right now, baseline. There's nothing in the original. The baseline folder didn't have a lot in it because that was the placeholder for the protocol code coming off of Radish 34. So now
it'll probably be called
baseline or core. That's where people you're going to want to import from there as opposed from Radish 34. So Radish 34 becomes a true example, and baseline or core will be where you're going to get all your packages from, or your libraries.
Yeah, where you can npm install them today. You can npm install these packages, and then you'll want to use this pattern right here, like npm install baseline protocol API. And there's a good example app that'll be you'll be able to look at it sometime this month, and you can run it and see how it works.
And anybody that wants to either help or get involved, or at least educate themselves on things as it's coming, it's all out in the open, right? It's all in init-core branch on the repo, which is Ethereum-Oasis or github.com/Ethereum-Oasis/baseline, right?
Yep.
Okay, so the last question is, what help do you need? Or I guess that was the second question, but what help do you need?
Yeah, I mean, I think things are going pretty well. We've been working with the community or at least the maintainers. I'd love for folks to get in and be savages on the PR when it's back open, just so we can sort of vet out, make sure everything makes sense to everyone. There's a lot of new code, there's a lot of new opportunities, but what's the incremental thing? I guess to Karthik's point, what's the just get on the PR and be savages when it's open. That's the thing I would really ask for.
That's right. We're still looking for new maintainers, right? And new technical steering committee members. Folks should know that so Kyle, thank you very much, Tomasz, Karthik, Brian. Let me give a couple PSAs here. First, folks should know that the technical steering committee, including my position as the chair, are up for votes in September. The way to get a vote in is there's only one way. You can't give us money. You can't be a sponsor. You can't, you can do those things, but you can't. There's only one way to get a vote for the technical steering committee, and that is to commit code. If it's even a spell check, you have to pull, go into the GitHub repo, commit something, pull request to the and if it's accepted to the master branch, then you have a vote and you're a contributor to Baseline. So get on there and do that, even if it's something small. That's how you get your vote. And
I know where a few typos are. Even there's some in there.
There you go. Go find the typos. I mean, it doesn't have to be a big piece of work, but it shows commitment, and you will have then signed the ICLA for the open source requirement. So that's how you get a vote for the TSC and for the governance of the body. So that's important, and that's coming up in September. September 30th will be when we announce the final parties in the TSC. It's an 11-member TSC, and very much like Hyperledger. And there you go. So everybody seeing this, get those commits in. Are there any final? Kyle, I know, has a number. Several demos are coming out in July timeframe as well. Really excited about that one with DocuSign, and there seem to be more and more coming out around systems like Salesforce and SAP. There's more coming out on SAP's stack. Unibright's doing a lot of work there as well, of course, and others. And then there's Microsoft Dynamics has been a big player, and more things are coming in. So keep an eye out for all those demos coming. And I'm sure, Kyle, you'd agree that those demos will be a lot easier to produce once we push Init Core to master.
Oh yeah, everything will be in examples. The examples directory. It's being updated on the daily, and we're moving pretty fast now. So we'll do our best.
Really exciting. It's exciting work. And it's just such an amazing community that's come around. Lots of big companies joining as well. So with that, we are at the top of the hour. We do have time for any last questions. If there is anything burning, anybody on the call, or I'm going to check over on YouTube. Looks like we had a pretty interesting conversation. If you missed it, in the chat on YouTube about zero knowledge and about TEEs, trusted execution environment, and where that might sit in a Baseline world. And so you check out the chat for that.
Hey, John, Andreas here. I actually do have like 3 questions. And that kind of sort of like segues what you just said. Number one is like, how do you guys envision the trusted setup to work? And you need a trusted setup for each new circuit, right? So that's one, unless you're looking at something like Plonk or Marlin, right? Which is a different approach. So that's sort of like 1 and 2. And 3 is the question is, so every time every update is a new zero knowledge proof, and you have the state correctness and consistency based on the Merkle tree. Have you guys looked at just including doing aggregate ZK snark, so you can just prove the entire history with one proof?
Yeah, that's definitely like something we want to look into. For one, because the Shield contract as it stands is not very performant. So absolutely, we're interested in looking into that. So it's just sort of like an iterative, once we get this stable, I think it will be a pretty high priority. Thomas, you may have something to add to that. Nah, good deal. Guess I got it.
Right. Andreas, let me embarrass you by, I put on the YouTube, Andreas Freund, everyone, genius for hire. If you have need of a genius, I highly recommend, the Andreas Freund brand of genius. So
Andreas is a nice guy for sure.
We're really grateful that, Andreas, that you're spending time thinking and working out these issues as well.
So what was your first question? I feel like there was
the trusted setup. I mean, between quote unquote trusted counterparties, it becomes like a mute point, and everybody was like, I trust your setup, whatever. right? But if you're going into a situation where you have, we have repos, multiple parties, not necessarily 100% trusted. So the setup needs to happen in a ceremony, right? So that's
Yep.
where keys could come in, MPC.
Yeah, I think MPC. I think MPC a lot for that, for sure. It's interesting. Cool. Yeah.
Okay, and we are at the top of the hour. Sometimes we do these for a half hour, but I think this one was deserving of an hour. Thank you, everybody, for staying on for the whole hour. And keep your eyes peeled on Baseline in July. It's going to be a big month. And with that, we'll sign off. Thanks, everybody, and happy baselining.
Thanks, guys.
Thank you.
See ya.